Okay, so the chapter now is on chemical bonding. So let us discuss the types of chemical bonding. The first type of bonds is called ionic bonds. And you should realize that an ionic bond is formed when I have one metal and one non-metal. So if I'm trying to make a bond between sodium and chlorine, for example, you know that sodium is group 1, that's a metal, and chlorine is group 7, that's a non-metal. So in this case, the bond that we're going to do is called an ionic bond. Now, how does the ionic bond form? It is formed when the metal loses its outermost electron and the non-metal gains an electron. Now, sodium, for example, is in group 1. It has 1 electron in its outermost shell. It doesn't want it because if it's going to lose it, then it will become 2,8, and that is a stable configuration. The atom is stable if its outer shell is full. And we said the outer shell is full with 8. So if I lose that outermost electron from the sodium, we become a 2,8, and that is a stable configuration. But in that case, when I lose an electron, that means now I have an extra positive charge. So the Na becomes Na+. Now, chlorine. Chlorine has how many electrons in its outermost shell? It's in group 7. It has 7 electrons in its outermost shell. It needs how many? It needs 1 more electron to be filled and become stable. So it will gain the electron from the sodium, and that means that now it has an extra electron, and that means it has an extra negative charge. Do not forget to write the positive and the negative. So if he says, write, this diagram is called the dot and cross diagram. So if he says, draw a dot and cross diagram for sodium chloride, that is the second part after the arrow. You don't need to start with whatever is before the arrow. Whatever is after the arrow, that is what you're supposed to write. So actually, the dot and cross diagram for sodium chloride is Na with a positive, Cl with a negative, and showing the outermost electrons. 7 of them belong to the chlorine and 1 came from the sodium. Okay, so this ionic bond is the strong attraction forces between positive and negative ions. Remember that if we have attraction between positive and negative ions, this is called electrostatic attraction forces. Now, what is the ionic bond? What bonds the sodium and chlorine together is the fact that one of them is positive and the other is negative, and there is a strong electrostatic attraction forces between positive and negative ions. Okay, so that is called an ionic compound. So you should remember, we said before in the previous chapter, an ion is an atom that has lost or gained electrons. If it loses electrons, it becomes positive, and that is called a cation. If it gains electrons, it becomes negative, and that is called an anion. Okay? Okay. Now, the ionic compounds, if we ask about the structure of the ionic compounds, the structure is called ionic crystal lattice. So this arrangement of positive and negative ions is called a crystal lattice. Remember that when I have sodium chloride, I don't just have one sodium next to one chlorine and that's it. I have actually a giant 3-dimensional structure with regular arrangement of alternating positive and negative, positive and negative, positive and negative, and so on. So actually I have a large compound with a lot of sodium and chlorines that are arranged alternatingly, one positive, one negative, one positive, one negative. In that case, that means that for each positive ion, there are 6 negative ions surrounding it. That's because for one positive, there is a negative above, a negative below, a negative on the right, a negative on the left, a negative in front, and a negative at the back. So that is 6. The same if we're looking at a positive ion. A positive ion will also have 6 negative ions surrounding it. Okay? And this structure is held by strong electrostatic attraction forces between the positive and negative ions or the oppositely charged ions. So if he says describe the structure of any ionic compound, we say first of all it's an ionic crystal lattice. It is giant 3-dimensional structure with regular arrangement of alternating positive and negative ions. Sometimes he gives you more marks, or he allocates more marks to the question then in that case you can go on and say each positive ion is surrounded by 6 negative ions and each negative ion is surrounded by 6 positive ions. Okay, now based on that you should be able to explain the physical properties of ionic compounds. So for example, ionic compounds have high melting and boiling point. Now why would it have high melting and boiling point? Because there is strong attraction forces between what? Between positive and negative ions in the giant crystal lattice, which need high temperature to break them or a lot of energy to break them and separate the ions. Okay, but what if I am comparing between something like magnesium oxide that has 2 positives and 2 negatives and something like sodium chloride that has only 1 positive and 1 negative? Now the more charges means more higher melting point. So something that has 2 positives and 2 negatives will have a much higher melting point than something that has 1 negative and 1 positive. This is because the increased charges on the ions form stronger attraction forces that need more energy to be broken. Please learn these explanations. Okay, another physical property is that ionic compounds will dissolve in water. They do not dissolve in organic solvents such as ethanol. Remember that things either dissolve in water or in organic solvents, and the example of organic solvents that we have is ethanol. Now, with respect to conduction of electricity, ionic compounds conduct electricity when molten or in solution because positive and negative ions are free to move. Remember that ionic compounds contain positive and negative what? Ions. They don't conduct electricity when solid, and that is because the ions are not free to move. Okay, so let's write dot and cross diagrams. We've written dot and cross diagram for sodium chloride. Let's write it for other things. For example, lithium fluoride. Lithium has 1 electron in its outermost shell. Fluorine is in group 7. It has 7 electrons. So we said the lithium doesn't want that outermost electron. It will lose it and give it to the fluorine. And that means that the lithium will end up with an extra positive charge. Now, the fluorine, you have to indicate the outermost electrons. Usually the question says using the outermost electrons, or we call them the valency electrons. So the outermost electrons or the valence electrons, fluorine has 7 of its own in the outermost shell, and it took 1 from the lithium, and now it has an extra negative. Do not forget to put that extra negative on the fluorine. Okay, what about magnesium oxide? Magnesium has 2 electrons in its outermost shell, so it's going to lose them and become +2 or 2 positives. Now, oxygen has 6 electrons in its outermost shell, so it needs 2. So it's going to take the 2 from the magnesium, and that means that it has extra 2 electrons, and that means it has a -2 or 2 negatives. Okay, what about magnesium chloride? Magnesium has 2 electrons, but each chlorine has 7, and it needs only 1. Remember that chlorine has 7, it cannot take more than 1. And magnesium has 2 in its outermost shell. It has to lose the 2. It cannot lose only 1 of them. So that means that I need 2 chlorines to take the 2 electrons from the magnesium. And that means the magnesium ends up with a +2 charge on it, because now it has lost 2 of its electrons. And each of the chlorines has 1 negatives because it gained 1 electron from the magnesium in addition to its 7. So it has 1 extra negative charge. Okay? Now, sodium oxide. Let's talk about sodium. Each sodium has 1 electron in its outermost shell, but oxygen has 6, so it actually needs 2. So that means that I need 2 sodiums to give me 2 electrons to fulfill the oxygen's full outer shell. And that means that each sodium loses 1 electron, so each sodium is an Na+ with an extra positive. Now, the oxygen has 6 of its own +2 that it took from the sodium, so it has 2 extra negative charges. Okay, let's try this sample question. Which substance is an ionic compound? What did we say about ionic? Do you understand the meaning of volatility? Something that is volatile, and if it has high volatility or it is volatile, that means that it evaporates easily. And if it evaporates easily, that means its boiling point is low. Now, What did we say about ionic compounds? Its boiling point is high. Now, if something has a high boiling point, then its volatility is low. That means it will not evaporate easily. So actually, ionic compounds have low volatility. Now, what about electrical conductivity when molten? Yes, when molten, it should be good. Solubility in water, it dissolves. So my answer is C. Okay, the other kind of bond is bond between two nonmetals. So if we're trying to make a bond between two nonmetals, now that is called a covalent bond. A covalent bond involves sharing of electrons in order to have full outer shell. So if I have two nonmetals, they're going to share electrons between them. That means each of them is going to donate 1 or 2 or 3 electrons, and this bond is called covalent bond because it is an attraction force between the positive nuclei of the atoms and the electrons that are being bonded. So remember that the covalent bond is actually the attraction between the bonding pair of electrons, the shared electrons, and the positive nuclei of the atoms. And this happens only when we have two nonmetals together. So if we're trying to write dot and cross of hydrogen, and remember, you need to know how to draw these dot and cross diagrams. Please sit down and practice them. So hydrogen molecule, remember that there is something called hydrogen atom and there is something called hydrogen molecule. The molecule means hydrogen is trying to bond with another hydrogen. Okay, so when we have hydrogen molecule, that means I have two hydrogen atoms. Now each hydrogen has 1 electron out in the shell. How many electrons does it need? Remember that this is the first shell, and the first shell takes a maximum of 2. So actually each hydrogen needs only 1 electron. Now where is it going to get it? It's going to get it from the neighboring hydrogen, and that means each of these two hydrogens are going to donate 1 electron. So I have 2 electrons in the middle between them that is being shared by both atoms. So it is as if these 2 electrons belong to both atoms. Now you can draw this with circles as I drew it, or you can draw it without circles, whichever is more easy or more reasonable to you or easier to you. With or without circles is correct, so long as you have 2 electrons that are being shared between the 2 hydrogen atoms. Now what if I'm trying to draw chlorine? Now each chlorine atom already has 7 electrons in its outer shell, but it needs how many? It needs 1 more. So each of these, if it needs 1, that means it's going to donate 1 and take 1. And that means between the 2 chlorines, I have 1 of each electron, 1 electron from each atom, and I still have the rest of the 7. So you don't forget to put in the rest of the 7. You still have 6 more electrons around the chlorine. Again, you can either draw it with circles as it is drawn here, or draw it without circles, and that is fine, so long as you have only 1 pair of electrons between the 2 chlorines, and each chlorine has the rest of its 7 around it. Okay? Now water. How do we draw water? Water, you should know, is between hydrogen and oxygen. But each oxygen needs how many? Each oxygen needs 2 electrons. It already has 6 in its outer shell, so it needs 2 electrons. But a hydrogen can donate only 1. So actually I need 2 hydrogens to donate 2 electrons to the oxygen. So you draw it either with circles or without circles, so long as you have only 1 pair of electrons between oxygen and hydrogen, 1 from the oxygen and 1 from the hydrogen, 1 from the oxygen and 1 from the hydrogen. And then I still have the rest of the 6 that belong to the oxygen. I need to put them away to indicate that they are not being shared between the oxygen and the hydrogen. Do we understand that? Okay. Now when I share a pair of electrons like this is called a single covalent bond. So the covalent bond is where we're sharing a pair of electrons. If it's 1 pair, it is called a single covalent bond. Methane. Methane is a compound that is made up of carbon and hydrogen. You should realize each hydrogen can donate 1. But the carbon needs how many? Carbon is in group 4. It needs 4 electrons. So I need 4 hydrogens to give me 4 electrons. So I draw it like this, so that between each carbon and hydrogen there is one from the carbon and one from the hydrogen, either with circles or without circles. Okay, ammonia. Ammonia is a compound between nitrogen and hydrogen. Again, each hydrogen can give me only one, but then the nitrogen needs how many? The nitrogen has 5, it's in group 5, so it has 5 electrons in the outermost shell. So it needs 3, and that means I need 3 hydrogens to donate 3 electrons. So I have 3 pairs of electrons being shared between nitrogen and hydrogen, and I still have the rest of the 5. Please do not forget, to put in the rest of the outermost electrons of the atom. So nitrogen has a total of 5. It's going to use only 3 to make bonds with hydrogen, so it still has the other 2 left on top. Okay, hydrogen chloride. Hydrogen chloride is between hydrogen and chlorine, and you should realize that chlorine has 1 electron. It needs, chlorine has 7 electrons and it needs only 1, so it's going to share 1 pair with hydrogen, and we said sharing 1 pair of electrons is a single covalent bond. What about oxygen? We said oxygen molecule means oxygen with oxygen. Now, oxygen with oxygen, each oxygen has 6. It needs 2. So each of them is going to donate 2 and take 2. Donate 2 and take 2. And that means that I have 2 pairs of electrons being shared between the atoms. This is called a double covalent bond. Between nitrogen and nitrogen, each nitrogen has 5, so it needs 3. So it's going to give 3 and take 3. So we have 3 pairs of electrons being shared. Don't forget to put in the rest of the 5 for each nitrogen. So each nitrogen has 2 electrons that are not involved in the bonding. That means I am sharing 3 pairs of electrons. This is called a triple covalent bond. Carbon dioxide. Carbon dioxide is carbon. Carbon has 4, so it needs 4. But each oxygen can donate only 2 because the oxygen has 6 and it needs 2. So between the carbon and each oxygen, you're going to have 2 pairs of electrons, 2 from the carbon and 2 from the oxygen, so that the oxygen now has 6 of its own plus 2 from the carbon, so it is full. Now the carbon in the middle took 2 electrons from each oxygen, so it has 4 and it took 4. These are 2 double covalent bonds. Ethene. Ethene is 2 carbons with a double bond and hydrogens. Now, it is C2H4. So C2H4, each carbon needs 4 electrons. It's going to take 2 from the hydrogens. That means it needs to take 2 more from the neighboring carbon. And that means that I have a double covalent bond between the 2 carbons and single covalent bonds between the carbons and the hydrogens. Methanol. How do we draw methanol? I'm telling you for now that methanol is CH3OH. That means I have a carbon with 3 hydrogens around it. Each of them will give 1 and take 1. Now I need 1 more, so I'm going to take it from the oxygen, but the oxygen needs 2. So it will take 1 from the carbon and 1 from the hydrogen. Remember that your notations are either a dot or a small circle or an X with a circle. These are the general, so this is the kind of structure that you will have. Okay, so this is a typical question. A molecule of silicon tetrafluoride, and I'm telling you that it's silicon with 4 fluorines, contains covalent bonds. That's correct, because both silicon and fluorine are non-metal. Now draw a dot and cross to show the outer electrons in these molecules. So let's look at the fluorine first. Fluorine has how many electrons in its outermost shell? Past 7. It needs how many? It needs 1. So between each fluorine and silicon, I'm going to have 1 from the fluorine and 1 from the silicon. 1 from the fluorine and 1 from the silicon. Now why do we have 4 fluorines? Because silicon is in group 4. It has 4 electrons of its own, so it needs 4 more. But each fluorine can give me only 1, so I need 4 fluorines to give me 4 electrons. Okay, what about this? Complete dot and cross diagram to show the electron arrangements in a molecule of ethanol. So this is the molecule of ethanol. Now, first of all, you should know that each hydrogen has one and needs one. So we're going to give each hydrogen one and take one from whatever is next to it. Now the carbon is in group 4 and it needs 4 more. So if it takes 3 from the hydrogens, it needs 1 from the neighboring carbon. So between the two carbons, I have 1 pair of electrons. Now what about the oxygen? The oxygen has 6 of its own. It needs 2, so it's going to take 1 from the carbon and 1 from the hydrogen, and it still has the rest of its 6. Do not forget to put the rest of its 6 electrons around it. Okay? Now, with respect to physical properties, you should remember covalent compounds have low melting point and boiling point. Why? Because they have weak attraction forces between molecules. Remember that if we're talking about covalent compounds, they are small molecules. Melting point or boiling point has to do with how much energy do I need to separate these molecules from each other. So if they're small molecules, these molecules have weak attraction forces between them. So if I just give it a little bit of heat, they will separate. And that's why they have low melting and boiling points. The ionic compound, do you remember what we said about ionic? The ionic compound had what? Had high melting point. And we said, why does it have high? We said because it is actually made up of many positive and negative ions, and there is strong attraction forces between the positive and negative ions, and that needs a lot of energy to be built. Okay, if we say that covalent compounds have low melting point, that means they are volatile. Remember we said the word volatile means they evaporate easily, and if they evaporate easily, that means they have low melting point. Okay. Covalent compounds are they're usually solids or gases. I'm sorry about this mistake. They're usually solids or gases at room temperature, except bromine, which is a reddish brown liquid. So sorry, they're usually solids or gases, not liquids. The only liquid non-metal is bromine. Okay, covalent compounds are not soluble in water. They dissolve in organic solvents, and we said an example of organic solvents is ethanol. Covalent compounds do not conduct electricity, whether it's molten or in solution or as a solid. So usually they do not conduct electricity due to the absence of free ions. Now, let's talk about the structure of compounds. We can have two types of structures. We can have simple molecular structure, or we can have giant structures. So, simple molecular structures, most elements have simple molecular structures. For example, iodine, carbon dioxide, chlorine, hydrogen, whatever, all of these things that have low melting points are simple molecular structures. And if he says why something has low melting point, that is probably because it has simple molecular structure, and this is because the simple molecules have weak attraction forces between them. So iodine, for example, the bond inside is covalent, and the covalent is strong. But when we're talking about melting point or boiling point, that has to do with the forces between the molecules. So between each iodine I2 and another I2, there is attraction forces that can be broken down easily. Also, carbon dioxide molecules, so one carbon dioxide and another carbon dioxide and so on, between them there is weak forces, weak intermolecular forces, and this is what determines the melting point, because when we're melting, we're trying to separate the molecules from each other. So simple molecular structures will have no melting point, and if he says why they have low melting point, it is due to weak attraction forces between the molecules. Okay. But other substances have giant structures, and the word giant means macromolecular. So if he says what is meant by macromolecular, it means a giant structure, large three-dimensional structure in which many atoms are strongly bonded together. Then we call that a giant macromolecular structure. So which ones are we going to study that are macromolecular or giant? Ionic crystals, we've already talked about that. Ionic crystals have giant three-dimensional structure with many positive and negative ions attracted to each other. So that is a giant structure. Metals, we're going to talk about it. This is also giant. Diamond, graphite, silicon dioxide, All of these are giant macromolecular structures. And remember, if something is giant, that means it has high melting point, since it has strong bonds between the atoms or the ions in the giant structure that need a lot of energy to be broken. So let's talk about each of these. The ionic crystal, we already talked about it. We said it is in form of crystal lattice. This crystal lattice is a giant three-dimensional structure with regular arrangement of alternating positive and negative ions. And we said it usually has high melting point because it is held by strong attraction forces between the oppositely charged ions. So the fact that we have many positive and negative means I have strong electrostatic attraction forces between them, and this needs a lot of energy to be broken. Now, what about metals? If we're talking about a metal, we said metals are in group 1 or 2 or 3. That means that they have 1 or 2 or 3 electrons in their outermost shell. And that means it doesn't really want these 1 or 2 or 3 electrons because it will prefer to lose them and have a full outer shell. So each atom actually of the metal has these outermost electrons floating around them. Okay, so we say that the metallic structure, of course, the metal is a solid. So, and we said before that solids are regular rows close packed. So a metal also is regular rows close packed. But regular rows of what? If its outermost electrons are slightly away from the atom, then it's not an atom anymore. It's a positive ion. So metals are made up of regular rows of positive ions surrounded by a lot of electrons that are slightly floating around. So we call that delocalized electrons. So if we're explaining the structure of metal, we say giant three-dimensional structure with regular rows of closely packed positive ions surrounded by a sea of delocalized electrons, as if the electrons are floating around like a sea. Okay, and you should know that metals have high melting point and boiling point. Now, in this case, why do we have high melting point and boiling point? Because of the strong electrostatic attraction forces between what? What do we have here? We have positive ions and negative electrons. Please pay attention to these explanations. Why do ionic compounds have high melting point? Why do metals have high melting point? Why do simple structures have low melting point? So, with respect to a metal, high. Why is it high? Strong electrostatic attraction forces between what? Between positive ions and negative electrons. Now, if we're asking about physical properties of all metals, you have to remember that all metals conduct electricity, all metals are malleable and ductile, all metals are shiny. These are physical properties that apply to all metals. Don't mention melting point because it could be low or high, relatively. Don't mention anything else. All metals conduct electricity, malleable and ductile, shiny. Now, first of all, why do they conduct electricity? When solid, remember, and the metals are the only ones that will conduct electricity when solid. Metals conduct electricity when solid, and of course when molten or liquid or whatever, due to the presence of what? Due to the presence of free electrons. Remember, when we were talking about ionic compounds, we said they conduct electricity because they have free moving ions. Metals have free moving electrons. Now, all metals are malleable and ductile. The word malleable means they can be spread into sheets, just like aluminum foil, for example. And ductile because they can be stretched into wires, like the copper wires that we have. Now, why are metals malleable and ductile? We say because the layers of positive ions can slide over each other when hit with a hammer or when the metal is hot, since the atoms have more energy and are vibrating faster. Okay, so we said metals are made up of layers of positive ions. Now, why are they malleable and ductile? Because these layers of positive ions can slide over each other when heated or hammered. And this is because when you heat it, the atoms have more energy, vibrating faster, so they can move. And of course, all metals are shiny. So let's see this sample question. State why metals such as titanium are good conductors of electricity. We said they're good conductors of electricity because they have what? delocalize the electrons that are free to move, or you could just say free moving electrons. Explain why metals such as titanium are malleable. We said, why are metals malleable? Layers of positive ions can slide over each other. Okay, another example of a giant macromolecular structure was diamond and graphite. Diamond and graphite are allotropes of carbon. The word allotrope means two forms of a certain element in the same state, but they have different structure and different physical properties. So both diamond and graphite are made of carbon. But the difference between diamond and graphite is that the carbons are arranged in different ways. So we say they are allotropes of carbon. So let's take a look at diamond. What is diamond made of? It's made of carbon. Now, how are the carbon atoms arranged? They are arranged in giant three-dimensional structure. So this is a giant three-dimensional structure in which each carbon atom is covalently bonded to how many? Each carbon atom is bonded to 4 other carbon atoms. And this forms a rigid tetrahedral structure. This structure in which you have the carbon in the middle, 1 carbon on top, and 3 carbons like a pyramid below. This structure is called a tetrahedral structure. So you have to remember that diamond is giant three-dimensional. Each carbon atom covalently bonded to 4 other carbons in a rigid tetrahedral structure. Now, based on that, because it has that structure, diamond is hard. And actually, diamond is one of the hardest things. So, diamond is hard. Why is it hard? Because of the strong covalent bonds between carbon atoms in the rigid three-dimensional tetrahedral structure. So, basically, because it has this kind of structure. Now, diamond does not conduct electricity because it doesn't have what? It doesn't have free electrons. Each carbon atom has 4 electrons around it. It's already using the 4 electrons for bonding, so it doesn't have any extra electron to float around. So it doesn't conduct electricity because there is no free electrons. Diamond is used in cutting and drilling. We said diamond is hard. And because it's hard, we use it in cutting and drilling. So it's used in cutting and drilling equipment because it is hard, since it has strong covalent bonds between carbon atoms in the rigid three-dimensional tetrahedral structure. Please learn these explanations and understand them and try to write them correctly. Graphite. Graphite is also made of carbon, but it is made up of layers. So this is again a giant three-dimensional structure in which each carbon atom is covalently bonded to how many here? Each carbon here is covalently bonded to 3 other carbon atoms. And it is made up of layers of 6-sided rings with weak attraction forces between the layers. So graphite is giant three-dimensional. Each carbon atom is covalently bonded to how many? 3 other carbon atoms in layers of 6-sided rings with weak attraction forces between the layers. That's the structure of graphite. Now, based on that, graphite is soft, and because it is soft, it's used as a lubricating agent or as a lubricant. Now, why is graphite soft? You should know that this is because of the weak attraction forces between the layers that allows them to slide past each other. So we said the layers have weak attraction forces between them. This allows the layers to slide over each other. Now, graphite conducts electricity. This is because it has free what? Electrons. Remember, ionic compounds conduct electricity because they have free ions. Metals conduct electricity because they have free electrons. Graphite conducts electricity, and actually graphite is the only non-metal that conducts electricity because it has free electrons. And this is because each carbon has 4 electrons in its outer shell. It's using only 3 to bond with the 3 carbons, so it has the 4th electron floating around. Now, what do we use graphite for? We use it as a lubricant because it is soft, and as an electrode because it conducts electricity. The other thing that we're supposed to study is silicon dioxide. Silicon dioxide is something very similar to diamond, giant three-dimensional tetrahedral structure, but in this case we're not made of carbon, it is made of silicon and oxygen. Now silicon is in group 4, so it needs to make 4 bonds. Oxygen is in group 6, so it needs 2 electrons. That means it makes 2 bonds. So this is a giant 3-dimensional tetrahedral structure in which each silicon is covalently bonded to 4 oxygen atoms, and each oxygen atom is covalently bonded to 2 silicon atoms. Can you see that? Okay, so if we say silicon and carbon are both in group 4, then they should have similar chemical properties. But actually, silicon dioxide is a solid while carbon dioxide is a gas. And why is that? This is because carbon dioxide is made up of molecules with weak attraction forces between them, while the silicon dioxide is a giant 3-dimensional structure with strong covalent bonds between the atoms that need a lot of energy to be broken. So carbon dioxide has weak attraction forces between the molecules. It needs just a little bit of energy. The silicon dioxide contains strong covalent bonds between the atoms that need a lot of energy to be broken. Okay, let's try this. Use the information table to answer the following questions. Which of these do you think is a metal? A, B, C, or D? Now, a metal will have high or low melting point. It should have high melting point and high boiling point. Should it conduct electricity as a solid? Yes, we said metals are the only substances apart from graphite which conduct electricity when solid. So the metal here is most probably B. Now, giant covalent. Giant means high melting point, high boiling point. Covalent means conduct electricity or not? No. Covalent will not conduct electricity as a solid, will not conduct electricity as a liquid, so A must be our giant covalent structure. Now, which one is ionic? Ionic should have high melting point, high boiling point. But conduction of electricity, it will conduct electricity only when liquid, not when solid. So an ionic compound would be D. Which of these is a liquid at 25? Liquid at 25 means the melting point is lower than 25, the boiling point is higher than 25. So the liquid at 25 would be C. Which one is a solid at 1600? At 1600 it's a solid. That means its melting point must be above 1600. So it is A. Diamond and silicon oxide both have giant structures. Which statements are correct? Both substances are compounds. Which one of these is compound and which one is element? Remember that diamond is made of carbon, so that means it is element. Silicon dioxide is made up of silicon and oxygen chemically combined together in a Figg's ratio. Silicon dioxide is a compound. So when he says both are compounds are strong, diamond is not a compound. Now, there are strong covalent bonds in diamond. Yes, of course there is. Silicon oxide is bonded ionically. Did we say it's an ionic compound? No. Both substances have very high melting points. Yes, because both are giant. So that means 2 and 4 are the correct statements. Which statement about graphite and diamond is correct? Diamond has a high melting point, but graphite does not? No. Both of them are giant, so both of them would have high melting point. Now, graphite and diamond both conduct electricity? No. Only graphite conducts electricity. Graphite and diamond both have giant structures? Yes, they both have giant structure. Graphite is ionic? No, graphite is covalent. Okay, 3 statements about diamond, graphite, and silicon dioxide are listed. Which statements are correct? Diamond and graphite both have giant covalent structures? Yes. In silicon dioxide, silicon and oxygen are joined together by covalent bonds? Yes. Diamond and silicon dioxide have similar structures? Actually, that is correct. So the answer is A. Okay, so that's the end of the chemical bonding. Please go back and study the notes, PDF notes, revise the explanation, and try the chapterized questions, and we meet next time to explain the answers to the questions.